Dear participants, welcome you all. Previously, we have discussed about the one of the subfamily of fabaceae.
So now moving towards the next family, that is Caesalpinaceae. Now moving towards the today we will going to learn about the next one, that is the Caesalpinaceae. Earlier we have studied the starting from our previous discussion in which we have studied the one of the subfamilies of fabaceae, that is the Papilionaceae family. And today we will going to start the next one, that is the Caesalpinaceae family. So starting from the distribution of Caesalpinaceae family, this family is about 152 genera and 200 and 2800 species that distributed both in subtropical and tropical regions of the world. And India is represented by 23 genera and 80 species, and most of the plant are the trees like Tamarindus indicus, or sometimes maybe shrubs like Parkinsonia, or rarely herbs like Cassia. So generally or sometime occasion will be climbed by, as in case of a Cohonia. So this family also have a good representation in world as well as in India. And if you see the vegetative characteristics, the leaves are also alternate, stipulate, compound leaf, rarely simple as in case of Cohonia, and unipinnate as in case of a cassia, or bipinnate in case of Tamarindus. And the leaf base have a swollen, so they have a pulvinous. And in Begonia, the leaves is deeply emarginate and perhaps due to the fusion of the two leaflets. You can see here this is the leaves of Begonia, although it is called as a simple type, but maybe these two are formed by the union of the two leaflets, because most of the plant in this particular family they have a pinnately compound leaves. So maybe these two lobes are formed by the fusion of the two leaflets. And if you see the stem is erect, woody, or sometimes maybe herbaceous or climbing depending upon the habit of the plants. So this is the main point, that is the leaves are stipulate and pinnately compound. And if you see the inflorescence, it may be axillary or terminal raceme or panicles. They may be rarely cymose type. And the flower is mostly large and showy. As you can see here in this particular figure, the flower is a quite large and showy, bracteate. They have a complete iota, that means they have a both accessory as well as reproductive organ, bisexual, zygomorphic and pentamerous and hypokynous. And the sepals, if you see, they are basically generally they are 5 and connate or short or long tube, and odd sepal is usually anterior and they are often colored. So these sepals are also sometimes colored. And if you see the corolla is also 5 in number with free petals alternate with sacral and institution generally ascending imbricate type. Then if we see the next reproductive part, that is the androecium, the stamens are 10 or less. They are rarely numerous, but often some of the stamens reduced to staminates or altogether absent, as in case of cassia, 5 to 7, and Begonia there is a 3 to 5 are perfect rest are staminose. And anthers are diathecous, enrolled and divided by the longitudinal slits. So you can see here in this particular figure, these are the pinnately compound leaves. You can see, and these are the stamens. Here you can see these are the stamens, and this hook-like structure is the ganoecium. So if we see the ganoecium, the pistil has a single carpel with single locule, that is monocarpellary, and ovary is superior, and they have a 2 rows of ovule on the marginal presentation, and the style is simple with capitate stigma. So this is particularly, and the fruit is usually legume or pod and often become transversely septated in case of capsule. So here you can see these are the stamens, and there is a presence of this hook-like structure as we have seen in earlier image. You can see here, this one is the This is representing the gynoecium. So they have a marginal presentation that ovules are arranged on these particular margins, and this is stigma is capitate. So we can easily identify this particular family with monocarpellary, and here you can see the flora. These petals are 5 in numbers, and the induction number is vary from 10 or sometimes it may be less. And if we see the diagnostic character of this particular family, they are generally cheese and sharp, and the leaves, most important thing that is the leaves are stipulate, alternate, and mostly they have a pinnacle compound leaves. Flowers are hypogynous, zygomorphic, and calyx are gamosepalous and representing the descending imbricate type of estivation. Corolla is also 5 in number and they're showing the alternate ascending imbricate estivation. Androeciums are 10 when they are polyandrous. And some diplo, that is a diplostamina that is arranged in a 2 groups. Then you can easily identify this from the, if you have a confusion with the Fabaceae, where the stamens are arranged in a 2 groups, that is a dialopal condition. Here, the stamens are polyandrous, there's 10 in number, so you can easily, and they are generally arranged in 2, but it is called as the diplostamnus. And the ovaries monocarpellary superior with unilocular and marginal presentation. Here the fruit is lumentum. So if you see the plural formula, that is the bracteate, calyx is 4 to 5, corolla is sometimes also 4 to 5, androecium is 10 to infinite, and gynoecium is monocarpellary superior. And most of the plant of the hybrid of this particular family is tree or generally shrubs. Rarely they are climbers. The most common example of this particular family is Tamarindus indica, that is Imli, Borneo, that is the Kachnar, Cactus, that is the Senna, Parkinsonia, or Saraka, that is Ashok tree, Cassia fistula, Maltas, Delonix regia, Gulmohali. There are some common examples of this particular family. And the most common one is the Bohemia variegata. So if we see the Bohemia in this image, you can see the Bohemia variegata, that is image source from the Google. So you can see and identify this particular family. This plant, here you can see the leaves are although simple in case of a Bohemia, but there's a deep margin, they may be united by the presence of a few leaflets. They are showing the alternate arrangement of the leaves. And here you can see the base is swollen. Then next, if you see the ileus of the flower, you can see there is a marginal presentation, that is gynoecium is made up of monocarpellary ovary. Style and the stigma is capitate, and there are only 5 androecium you can see here in this particular floral diagrams. And anthers are, you can see there is a bithecus and the ovary which have a one locule and marginal presentation. So if you see the floral diagram, that the flower are bracteate and the calyx is presented by 5, they are gamosepalous. Corolla are 5, that is, you can see they are 3 and showing the implicate estivation, androecium number is also 5, and they have a monocarpellary ovary with marginal presentation with single locule. So if you see the floral formula of this Borneo variegata, they are the zygomorphic. Then they are bracteate, zygomorphic, calyx number is 5, they are gamosepalous, corolla is also 5, androecium 5 or plus then 5. Then the gynoecium is represented by the monocarpellary and generally they are superior in position. And if we see the economic importance of this particular family, that is Caesalpinaceae. The most important plant of this particular family, generally they have a medicinal importance like Cassia lata, which is used to cure the ringworm and skin diseases. And the leaves of Cassia senna and Cassia ovata are used in making the drug called as senna, and this oil is applied extremely for the skin diseases. Then vegetables and fruits, the leaves and flower bud of Borneo variegata are used as a vegetables. And the deep fruit of Tremendous indicus are edible. all of you are maybe eating the Terminus indica, that is the imli plant. Then many of the species are also ornamental, like Bohonian variety that is called as Kashnar, Cassia, Delonix regia, that is Gulmohar, Caesalpinia, Pulcherrima are used as ornamental plants. And many of the plants are also used as a tanning and dyes, like bark of Bohonia and Terminus indica is used in the tanning, and hardwood of Hematoxylon that is used, red orange dye that is used in the dye. So there is some economic importance of the family, that is Caesalpinaceae. Now moving toward the next subfamily of the Fabaceae, that is the Mimosaceae. And if you see the distribution of Mimosaceae, this family has around 56 genera and about 2,800 species, which is widely distributed in subtropics and tropical region of the world, and is represented by 15 genera and 72 species in India. And mostly are the trees like Acacia, Albizia, or shrubs, and rarely there are climbers or hops like Neptunia or woody climbers, that most of them are the xerophytes. So moving forward to the characteristic of this particular family, Mimosaceae, and one of the most important characteristics of this particular family is their leaves. Leaves are alternate like other subfamilies of the Fabaceae, Papillinaceae or Caesalpinaceae. They alternate, stipulate, pinnately compound, and the stipules are modified into thrones because most of the families in this particular family have a xerophytic adaptations. So earlier we have there in the paper Papillinaceae that the stipules are modified into the polis structure, and in the Caesalpinaceae there is a stipule present. But here you can see the stipules are modified into the throne structure because they have adaptations in the xerophytic condition. And the leaves of Mimosa and Neptunia are sensitive to touch and assume sleep motion. This is the one of the very important physiology that is showing in these particular plants. And if we see the stem, mostly they are woody, they have a tannin sac and gum passages are common in the pith and the medullary race. Therefore, some species of this particular family are also used for the gum production, that is very important part of this particular family. So they have a pinnately compound leaves. You can see either they have a unipinnately or bipinnately. You can see these are the pinnately compound leaves, which is one of the characteristics of this particular family. Then you can see the floral characteristic, starting from the inflorescence. There are many manual flower condensing spike-like head or umbel. As you can see here, this is the flowers, inflorescence, and they are rarely racemose or globose umbel. So these condense spike-like head or umbel form, and the flowers are bisexual, actinomorphic, hypogynous to slightly perigynous and bacteriate. And if you see the calyx, they have a 4 to 5 sepals, and 3 sepals are fused to tube and 2 the lobed, and vegetation is valvate to indicate in case of a calyx. And if we see the gynoecium, this particular family, the pistil has a single carpel, that is a monocarpal with single locules, and the ovary has a superior and unilocular with similar ovules along with the ventral suture on the marginal placentation. So the style and stigma is also one, and the fruit is usually legume or pod in this particular family, and they are indehiscent, and the several species of acacia sometimes also have a lumentum type of a fruit. As you can see here, these are the fruits of this particular family. Now moving towards the corolla, they have a 4 to 5 petals, and petal may be pre or venated tube, and the institution is valvate in case of a corolla. And now moving toward the reproductive part, that is the anthurium. And the number and the cohesion of stamens show much variation in acacia, the numerous stamens which are free, whereas in albizia there is an indefinite stamens, mononucleus at the base. So in several genera, the stamens are twice the number of petals or 3, sometimes as many as the petal as in case of mimosa, and sometimes the filaments are long, filiform when often exuded. So there is a variation in case of the androecium and their cohesion also. So there's a quite variation that shown, and generally the anthers are dithecous, enclosed and delised by the longitudinal cells. So you can identify this particular families, subfamilies of the Fabaceae. Like in the first one, generally they have a diadelphous condition, and the number of stamens are 10. Then the next, in case of a Caesarpinaceae, you will find that generally they have a 5 to 10 instrument in the two rows. Here the variation there generally they have an infinite number of number of instruments and there's a much variation. So we can identify these three families from the basis of their androecium. And if you see the gynoecium, the pistil has a single carpus. So one of the bases that is the all these family belong to the some families to the same family, that is the presence of pistil, because all of them have a monocarpellary single pistil with a marginal presentation. So it is a superior ovary with unilocular and they have a marginal presentation and the stellar stigma is also one. And the fruit is usually a legume or pod and that ending in several species of acacia dengue. And the acacia that has a lumentum type of a fruit. And if you see the diagnostic features of this particular family, Mimosaceae, generally they are trees or shrubs and the leaves are pinnately compound, as you can see the one of the characteristic of the family. And they also have a stipules that converted into the thorn-like structure. So one of the characteristics of this particular plant is the presence of this particular thorns. The flowers are hypogynous to slightly perigynous with radial symmetry. Corolla are membranous and volvulate in bud. Stamens are numerous, distinct to strongly monoderpous and usually more showy than the perianth as we have seen earlier. And the ovaries monocarpellary, superior, unilocular and with marginal presentation. And the fruit are legume or lumentum acacia. And if you see the floral formula, they have a bracteate, calyxes, 4 to 5, corolla is also 4 to 5, addition number is infinite and the gynoecium is made up of single monocarpellary ovary. And if you see the common examples of this particular term, that is the Acacia nilotica, that is commonly called as babul. Then Acacia catechu, that is the hair. Albizia sebbae, that is the series. Mimosa cordica, that is the sensitive plant, that is touch me not. Then Prosperous glandulosa, Prosperous cinellaria, then Leuconaria, that is the bipenny. These are some common examples representative of this particular family. And one of the most common plant, that is the Acacia nilotica, which is also called as the Kajnath. So you can see bubblegum tree. And medicinally, if you see the uses, Acacia nilotica has a long historical medicinal use in Ayurvedic, Unani and folk medicines. And treating diabetes, gonorrhea and hemorrhoids, this particular family has a many economically important values. Here you can see the image of the Acacia nilotica, as you can see that is showing. Here you can see the characteristics of this particular family, that is the pinnately compound leaf, their inflorescence, that is the condensed form. That if you see a single flower, halos of the flower, that is presence of a bract, calyxes, middle of 5, they are united. Corolla is also middle of 5, they are also united. The stamen numbers are infinite in number. So you can identify these particular families, subfamilies due to the presence of the androecium number. Then there is a single style, monocarpellary ovary with a single style and stigma. This one is the alias of the flower. Here you can see the fruit, that is the lumentum is in case of acacia. Here is the seed. And if you see the tiers of ovary, they are showing the marginal presentation. And this is one of the floral diagram. There you can see this is the floral diagrams are showing the bracteate flower, pipe calyx, corolla, number of infinite androecium and the one single monocarpellary ovary with marginal presentation. So if we see the economic importance of this particular family, this family is also used as a wood. Like many trees of this family provide a commercially important wood. For the example, many species of acacia like Acacia nilotica, Albizia, and Xylia, their wood is used for the construction for furniture and for the fuel. Then many plants of this particular family also yield gum. Like gum is obtained from the Acacia nilotica and Acacia senegal, used in medicine and confectionery and as a siding material in the textile industry. Then some plant of this particular family also have a medicinal importance. Like tender leaf of the Acacia nilotica are used as blood purifier, and the dye that is obtained from the Catacha, that is the katha, is obtained from the Acacia catacha that used in the industries and betel leaves in the preparation of the pan. So this is the economic importance of the family, that is Mimosaceae. And some plant of this particular family is also ornamental. Like some common plants are known for their beautiful flowers like Mimosa pudica and Acacia meranzina. The tannin which is mostly obtained from the bark of the Acacia nilotica, that is baboon, Acacia catu, that is the hair, and Acacia lycoprolia. And many of the plants are also used as a windbreaker, like few species of Prosperous, Prosopsis are planted in the arid zone for the breaking the wind pressure. And Prosperous glandulosa, Prosperous in area, they are also have a adaptation in the xerophatic conditions. So these about these three subfamilies of the Fabaceae. And if we see the affinities of the Fabaceae family, they have a affinities with the Solanaceae, like both the show the adaptations for the pollination, like Fabaceae has a legumes and the Solanaceae has the berries, capsules, and non-nitrogen fixation. And with Fabaceae, both have alternate leaves with stipule and some compound leaves. But the Fabaceae dip fruit differ in the groups and plumes, while Fabaceae has the leguminous fruits. And with Asteraceae, if you see, both adapt well to the various habitats. Asteraceae has a composite flower, where the Fabaceae has a solitary or seam flowers. So there are some affinities of this particular family Fabaceae with the different other families like Solanaceae, Rosaceae, and Asteraceae. So this particular family Fabaceae, which has three subfamilies, in which the most important one, that is the Papilionaceae, there is the presence of their all the pulses that we are consuming today, that all belong to this particular family Papilionaceae. And we can identify all these three subfamilies, Papilionaceae, Cisterpinaceae, Mamaceae, just on the basis of their androecium, because in the Papilionaceae, there is the Papilionaceous flower and the androecium are diadelphous with 9+1. In Cisterpinaceae, there is a 10 in number, but they are 5+ life. And in Mamaceae, you can see they have a infinite number of androecium. So you can easily identify this particular family, and they have a very peculiar monocarpellary ovary.
So this is all about the families of Fabaceae, subfamilies of Fabaceae. So hopefully you will identify these plants. Thank you all of you for joining me through this course. Thank you all.